All right, Algebra 1B students, welcome to part 2 of lesson 11.7 on graphing rational functions. Today we are going to use the asymptotes that we've been identifying in our previous video and our excluded values that we've been identifying throughout this chapter to actually graph rational functions, to actually graph some functions where we have an x in the bottom of a fraction. And we'll start with this example, where they're asking us to identify the asymptotes of the graph y equals -1 over x plus 3, all of that minus 4, and then graph the function as well. And so I'm going to start by identifying the asymptotes. And the asymptote, remember, our horizontal asymptote is given by that value there. The horizontal asymptote here is at y equals -4. It's the horizontal asymptote. Our vertical asymptote is related to this plus 3 right here on the bottom. Okay? But remember that plus 3 on the bottom with the x means we're moving to the left. So the vertical asymptote, instead of being x equals 0, is actually now x equals -3 because we have moved left 3. Okay, so we flip the sign on that vertical asymptote. So there's my two asymptotes, and I'm going to go ahead and put those on my graph right now, right away, first thing. See, horizontal asymptote, y equals -4. 1, 2, 3, 4 would be right here. So I'm going to just dash a line right there at x equals, y equals -4. That's my horizontal asymptote. My vertical asymptote is x equals -3. So that's 1, 2, 3 right here. So I'm going to dash a line there as well, a vertical line, and I'll scroll down so we can get the whole thing there. There we go. Great. So there's my asymptotes. I have got those. Now, I'm going to make a table of values, x and y, and try to see what this graph is going to look like. What you'll find is all of these graphs look very, very similar. There are two pieces that go in opposite directions that don't ever touch. But we need to figure out exactly where they are in this case. And just as a reminder, my function is this, y equals -1 over x plus 3 minus 4. Now, I'm going to pick values that are pretty close to my vertical asymptote as the x values in my table, but I need to pick some that are on the left of that asymptote, some that are on the right. So maybe I'll pick -4, and then I'll pick -6, and then I'll pick positive, maybe I'll pick -1, and maybe I'll pick positive, maybe -2. That'd be good. So I've got a couple on the left. -4 and -6 are left of my vertical asymptote. They would be here and here. Then I've got -1, -2 there and there. And hopefully I can see what's going to happen. Otherwise I'll grab some more points. But now I just need to plug these x values in to my function here and see what it does and see what my y value actually is. So if I put in -4, this ends up becoming -1 over -4 plus 3. Well, -4 plus 3 is -1, so it's -1 over -1. Well, that's just 1. Minus 4, I should be at -3 right there. -3. If I put in -6, then this value here is -6. -6 plus 3 is a -3. -1 over -3 is actually positive 1/3. Negative over negative is positive. Take away 4 is going to be -3 2/3. -3.7 if you did that on the calculator. -3.6. -3.7. So I'm going to plot those 2 points right now. Then I'll go to the right side of my asymptote and plot those points as well. But at negative 4, here I should be at negative 3, which is here. Okay? And then at negative 6, I should be at negative 3.7, which is getting pretty close to my asymptote. Okay? And what you'll find if you do more points is that it continues to get closer and closer to the asymptote. Right there, as we go to the left. It's closer and closer, but it can never actually touch. Okay? If I go with x equals negative 1, then that will make this value here be a negative 1. Negative 1 plus 3 would actually be a positive 2. So negative 1 over 2 is negative a half. Take away 4, this is negative 4.5, negative 4.5. So when I'm at negative 1, I should be at negative 4.5, which is right there. Okay, and if I'm at negative 2, that means this becomes negative 2. Negative 2 plus 3 is really a positive 1. Negative 1 over positive 1 is equal to negative 1. And if I take away 4, I'm at negative 5. So at negative 2, I'm at negative 5 right there. Okay? All right. Now, this side of my asymptote does very similar things in terms of the horizontal asymptote. It gets very, very close to it, but never actually crosses. So it does something like that. And then something strange kind of happens at that vertical asymptote. Okay? Now, I'm never allowed to cross this blue line here. This is my vertical asymptote. I cannot cross that. But as you can see, the function on the left, as I come with this piece here, is starting to turn upward, starting to get higher. And that's actually the case if I were to try something like negative 3.5 here in my x value. Negative 1 over negative 3.5 plus 3 is negative 1 over negative 0.5. Negative 1 divided by negative 0.5 is actually a positive 2. Okay. And then if I subtract 4, 2 minus 4 is negative 2. So I end up at negative 2 there, which is here. Okay, so hopefully you can see what this function is going to do. It's going to turn upward, and it's going to follow right along my vertical asymptote and go up forever, but never cross that line either. And then in a very similar manner, it's going to do the opposite on the other side of the asymptote. Okay, it's going to come down like this and get closer and closer to the asymptote, but never cross it. Okay, so it ends up being what essentially looks like two boomerangs that come close together and then bend apart. So every function where it's a number over x on the bottom of a fraction, so number on the top, x on the bottom, is going to look like this. Okay, it's just going to be shifted left, right, up, or down, something like that. Okay, they all will always look like this. Okay, but you do need to find a few values, put a few values in for x to kind of figure out where exactly these functions should be relative to the asymptotes. Okay, and here's what I mean by that. We're going to do one more example together, and then you'll be ready for your practice problem set. Okay, so let's look at this function here. They want us to identify the asymptotes and then graph the function f of x equals 8 over x minus 2 plus 3. 8 over x minus 2 plus 3. The first thing I will do is identify my asymptotes. This plus 3 here tells me that the horizontal asymptote is going to be at y equals 3. This minus 2 here tells me that the vertical asymptote is going to be at x equals positive 2 because I moved it right because I minused with the x. Remember, that's opposite, and outside is exactly what we would expect. So I will put my asymptotes here vertical at x equals 2, which is right there. And then the horizontal is at y equals positive 3, which is right here. Okay, so there's my two asymptotes now. And again, I'm just going to make a table of values to find a few of my points, but I know in general what this function is going to look like. Okay, now again, my function is y equals 8 over x minus 2 plus 3. Or I guess this actually says f of x, right? But we know that's the same thing. Y and f of x is the same thing. So let's see, I'll pick a few values for x on the left side of my asymptote and a few on the right side of my asymptote. Let's see, on the left side, maybe I'll go with negative 2, and I'll go with 0, and on the right side, maybe I'll go with, I don't know, maybe I'll go with 4, and I'll go with 10. Go all the way up to 10, see what happens. If I put negative 2 in for x right there, negative 2, take away 2 is negative 4. 8 divided by negative 4 is negative 2, plus 3 means this is still 1. Should be 1. Okay? If I put 0 in there, 0 minus 2 means this is going to be 8 over negative 2. 0 minus 2 is negative 2. The 8 divided by negative 2 is negative 4, plus 3 gives me a negative 1 here. So at 0, I should be at negative 1. And at negative 2, I should be at positive 1. Okay, that's interesting. If I put 4 in for x, let's see, 4 into here, 4 minus 2 gives me 8 over 2. That's 4. Plus 3 means 7. And then if I go out to 10, 10 in there, 8 over 10 minus 2, that's 8 over 8, which is equal to 1, plus 3 means that's 4. So, if I'm out at 4 in the x, 1, 2, 3, 4, I should be up at 7 in the y. 1, 2, 3, 4, 5, 6, 7 right there. And if I'm out all the way at 10, I should be at 4 in the x, which is right there. Okay? So, again, we know our function looks like two boomerangs that never cross, but are bending towards each other, basically. So, here on the left, it's going to look something like this, where it gets closer and closer but never crosses. And up here, it's also going to get closer and closer but never cross. Oop, maybe it crossed a little bit there. Oh well. And then here, it's going to do the same thing. It's going to get closer and closer and never cross. And down here, it's going to get closer and closer and never cross. So there's what our function looks like. Two bending graphs that never cross either one of our asymptotes. Okay? If you have questions about the process of creating these graphs, please make a note to ask me in class tomorrow. But it all starts with our asymptotes and then a little table of values, some on the left, some on the right. Otherwise, that's all I have for you. Have a wonderful night.